All right, this is working. All right, what's going on? I have an interview coming up, so I figured why not record myself, do some leet code. I'm not the greatest at leet code, and that's it. So let's start with single number. Given a non-empty, every element appears twice except for one. Linear runtime, constant extra space. Oh, this is just a XOR property. Basically, if you have a integer a and you XOR that with a, you get 0. So all the pairs are going to XOR into 0, and then 0 XORed with the last number is going to give us the number. XOR is just bitwise exclusive OR. So let's see here. Gnomes. Sweet. Have a list of problems here. This is from the 30-day leetcode challenge in like April. Okay, problem list. Happy number. Okay. There's the number. Or it loops endlessly in a cycle which does not include 1. Return true if it's a happy number, false if not. Is there some sort of quick math trick for this? Or do I actually just have to simulate the process? And how many times do I have to simulate the process? Is there a bounds for the number it gives us? Yeah, 2 to the 31 minus 1. Okay. Okay. I'm just gonna do it like a ton of times. Now, while n okay, so if n is actually 1, n equals 1, we're gonna return true. Otherwise, while m equals 0 plus equals, so we want the last digit squared, so m mod 10 times m mod 10. So that's going to add the last digit squared to cur, and then we have to finally divide it by 10. And now we have to okay, so this should be declared out here. And then we have to reset it, right? So n equals cur. N equals cur. right? Okay, so we do it a billion times. If it's 1, return true because it's happy. Otherwise, we have our temporary m and our next number. And we do this squared operation with m, right? And we're just adding it to this. Once we do it for all the digits, we now have the new number. N is now the new number. The new number is 1, return true. Okay, and then once this loop is done, we'll just return false. I'm just a little, oh, what? Output false, expected true. Okay, so for 19, okay, 19. And there's 19. So while m, right? Cur plus equals 9 times 9, 81. Now m is just 1. Cur plus equals 1, 82. And now m is not, okay, is it converting it to like a long or something? I'm going to say, well, maybe that was the correct condition. What? Print. Okay, what's going on? Okay. Oh, I see. What? What? Okay. How are we getting that for cur? Alright, this is like a... Okay, so it's this right here. In Python, how do you get it to not be a decimal? M equals int m divided by 10, maybe? Okay. Okay. Now, if this doesn't work, I think output limit exceeded. Output limit exceeded? Oh, is this because of this line? Okay, wow. I'm actually curious what the editorial says. Oh, I don't have premium. Because I just used this. Okay, so takeaways from that. Python does dynamic typing. So when you divide it by equal 10, it's just going to convert the int to a float. So you have to cast it to an int. I guess this thing just worked. Other than that, my logic was correct. So that's good. Next problem. Maximum subarray. Have I done this one? Oh, this is just, okay, I guess it's good practice. Right, this is just Cadane's algorithm. So let me think. I and range length of nums. So equals float. Oh, this goes in. Okay. So now the maximum subarray is either the number at I or the number at I plus our max so far. Right? Okay. So ans equals, okay, m equals max either at m plus nums at I or it's nums at I, and then ans is the max of what it is or m. And then we just return answer. Oh, there's a typo. Nice. Okay, glad I still have that in the noggin. What did I do last time? Oh, wow. I've actually done this many times. Looks like I've done it. Wow. Did I do it this way every single time? Okay, yeah, more or less pretty much the same. Okay, next. Best time to... Hang on. So I've done this one before. Let me just read this one again and remember how I did it. Choosing a single day to buy one stock and choosing a different day in the future to sell the stock. Okay, so if the number after the current number is less, you go forward. And then if it's more, then you buy, sell. Okay, and then in this one, you can hold that most one share of stock at any time. However, you can buy it and then immediately sell it on the same day. Okay, so you can buy and sell multiple times. But in this way, right, buy on day 1, sell on day 5. What if I just 1, 2, 3, 4? I think it's basically the same thing. You just add the difference of all the positive adjacent numbers. So like, okay, this is positively adjacent, this is not, this is. So you add 4 plus 3, 7. Okay, I think I got this. For I in range, length of prices. I feel like it should be kind of, I feel like it should be like much harder. But I think this works. I remember doing this before, like during, like a couple months ago with a friend. But maybe I'm thinking of a different problem. Because it says I've solved it, but I don't remember. From what I remember, it was much harder than this, so I guess we'll run into that now. If nope. If it's really just this, oh my god. Dude, wow. Was I even thinking of this problem? Yeah, so I did do it. Yeah, almost a year ago. Oh, it was the same thing? Oh, I just did it kind of weird. Okay. Nice. Next is move zeros. Modify nums in place. Given an integer, move all zeros to the end of it while maintaining the relative order. Oh, okay, so if we have this, then we move these to the end and keep this order. It has to be in place. Okay. Okay. So you have, I think this is just a 2 pointers question. So you have your 0 pointer, and then your num pointer, or I think I can just use I here, for I in range, length of num. So now as we loop through it, let me think. So we have our 0 pointer here, for I in range nums. If I is a number, then we just swap. Okay, then we keep going. If I is a number, then we swap. Okay, hold on. This is interesting. So what if go 0, 1, 0, 0, 3, 4. Right? We start here with the 0 pointer. Okay, I swapped. Now ZP's here. Keep going, keep going. Okay, I swap. ZP. Okay, so ZP only gets incremented once. Alright, so I think I got it. If nums at I. Then we just, is there a Python swapping function? Is it just swap? Okay, it is just swap. Oh, you can, oh yeah. You can just do that, okay. So nums at I, nums ZP, nums at ZP. So this is swapping. And now that. Right? And now we have to just move ZP to the first 0. So while nums ZP 0. Okay. I think this should work. Nice. Okay. So sometimes it can already just be done. Let's try now. Okay. This is the input 1, 0. Okay. So ZP will be 1 here. Okay, if num's at I, yes. So now we're here. And I is 0. Num's at 0, num's at 1, it goes num's at 1, num's at 0. Yeah. What's the big issue here? Right? Brian, if num's at I is 0, yes, ZP is that index. I starting at 0, yeah. So 0 pointer is 1. I'm a little confused. Is my swapping? Oh, hang on. Do you even need any of this? Let me see. It's an index, right? Let's say we have like 1, 2, 3, 0, 4. Okay. And let's say we don't even have any of this. ZP starts here. I starts here. Okay, I found a non-zero number. It swaps with ZP. ZP is here. Oh, I finds a non-zero number. Swaps at ZP, same thing. Okay, so it keeps going until I is going to skip this, go to 4, swap. Okay, so you don't actually even need to start the 0 pointer at the first 0. Let's use this test case. Okay, sweet. That worked. Yeah, yeah. I figured it had to do with, you don't need to do, I mean, this is very non-characteristic for a leetcode problem to have any sort of code like this. So I figured it's probably just simpler. Nice. Okay, next problem is, how many problems have we done? 1, 2, 3, 4. Wow, I've done 5 problems. How long has it been? Oh, almost 30 minutes. Okay. These are all easies. Group anagrams. Given an array of strings, group the anagrams together. You can return the answer in any order. Okay. Okay, so for each, so we need to have a map of all of our current anagrams, and we sort each string, and every time the sorted string matches something on the map, then we add it to a list we add it to the list of that specific anagram letter structure on the map. Okay, so storage. So the first thing we're going to do is just add, we're just going to add all the sorted anagram we're just going to add all the sorted words to this map and have them map to empty arrays. Actually, we can just do it all at once, can't we? For I in range strings. No, an I in range length of strings. Key is going to be strings at I sorted. If the key is already in our storage, okay, no, let's start with, if the key is not in our storage, then store at key equals, and then we'll initialize a list with the original string in it. Else if key and store, then store at key dot append the original string, and then at the very end we'll have a list. Okay, I don't think I can use list as the name of the array. For I and store, append store at. Okay, this should work. Unhashable type list. This is a list. What is this printing? What is this returning? Does sorted return an array? Oh. So I think we're going to do this dot join that. Does that work? Just makes it a string. Nice. Sweet. Wow. Okay, next is counting elements. It's locked. Okay. All right, well, that was all I had for this session. Cool. So I guess we can just, I guess the video's done. Yeah, so those were all easies. I think some mediums on there. Self-admittedly, I had done some of them before, but this was the first time I really looked at it after a while. And I guess it's a good thing that I was able to solve it, because if you can't solve it again down the line, then did you really learn anything the first time? You know what I mean? So cool. I'm gonna put together a new set of problems for tomorrow, and we'll start then. Thank you for watching.